All right, let's dive into the world of digital detectives. In an age where our entire lives are pretty much stored on hard drives and in the cloud, computer forensics is the science of digging up the truth that's hidden in all those bits and bytes. It's this high-stakes game where the crime scene is totally invisible, and the clues, well, they can vanish in a blink. I mean, really think about that for a second. When a digital crime happens, the evidence isn't just invisible, it's unbelievably fragile. It can be wiped out with just a single click. So how in the world do investigators piece together a story from data that somebody tried really, really hard to erase? That's the incredible puzzle we're going to unpack right now. Every investigation, right, it starts at the crime scene. But in the digital world, that scene might be a humming server room, or just a laptop, or even your smartphone. And the second an incident is discovered, a frantic race against time kicks off. Now, the first person on the scene isn't always some seasoned detective. It could be an IT admin, maybe a security guard, and their job is absolutely critical. Secure the area, and this is the big one, don't touch anything that could corrupt the digital evidence. Seriously, their first few moves can literally make or break the entire case. And this is exactly why every single second counts. Digital evidence is just so volatile. Think about it. The data that's in a computer's active memory or its open network connections, all of its temporary files, that stuff can just vanish forever with a simple reboot or if the power goes out. It is literally like trying to catch smoke with your bare hands. So to win this race against time, investigators followed this super strict protocol. It's called the Order of Volatility. You can think of it as their playbook for the crime scene, telling them exactly what to grab first, making sure those fleeting clues are saved before they disappear for good. And here's that playbook in action. It's fascinating because it's completely the opposite of what you'd think. You start with the most electric, temporary data, the stuff living right in the CPU and in RAM, which is gone the instant the power is cut. Only after all of that's secure do you move on to the more stable stuff on the hard drives. It's exactly like catching the smoke before you pick up the stones. Okay, so once the volatile data is captured and the devices are secured, they leave the chaos of the crime scene. Their next stop is the forensic lab, a sanctuary that's designed for one thing and one thing only, protecting the integrity of that evidence. You can basically think of a forensic lab as a clean room, but for data. It's physically locked down, access is totally restricted, and crucially, its network is completely cut off from the outside world. You just can't risk that evidence drive accidentally connecting to the internet and getting altered by a virus or a random software update. This is where the evidence is kept safe from any and all contamination. And this is the kind of gear they're using in there. You've got these powerhouse forensic workstations to crunch massive amounts of data. You've got specialized software. But maybe the most important tool of all is the write blocker. It's this incredible little device that makes it physically impossible to change the original evidence drive. It ensures you can look at everything, but you can't accidentally change a single bit. Now, with the evidence secured in the lab, the real hunt begins. This is where the actual detective work starts. The goal is to pull out the story that's hidden in the data, finding clues that maybe even the suspect didn't know they left behind. And there is one absolute, unbreakable cardinal rule in digital forensics. You never, ever work on the original evidence. Why? Because any analysis that changes the original in any way means it gets thrown out in court. It's useless. So, to get around this, investigators have to create a perfect, forensically sound copy. This is why a simple copy and paste just won't cut it for a criminal investigation. That method, it misses deleted files. It changes crucial timestamps. It's a mess. A forensic bitstream copy, on the other hand, is an exact bit-for-bit clone of the entire drive, and that includes the so-called empty spaces where supposedly deleted data still lives. And this is what's known as a bitstream copy, or a forensic image. It is a perfect mirror of the original drive. Every single 1 and 0 is copied over without exception. This copy becomes the investigator's playground, leaving the original evidence pristine and untouched, locked away in a secure location. So how do you actually prove that the copy is perfect? Well, you use a process called hashing. A hash algorithm basically creates a unique digital fingerprint for any piece of data. If the fingerprint of the original drive perfectly matches the fingerprint of the copy, you have mathematical proof that your image is an identical, untainted clone. It's airtight. Now, running alongside all this technical stuff, there's a crucial legal process. It's called the chain of custody, and you can think of it as the evidence's biography. It's this super meticulous log that tracks every single person who has handled the evidence, from the second it was seized until the moment it's presented in court. This is how you prove it was never left alone or tampered with. And here's a simple example of what that log looks like. From Officer Smith at the scene to Analyst Jones in the lab, every single handoff is documented. Date, time, signature, the whole shebang. An unbroken chain means the evidence is legally solid. But a single broken link, one undocumented moment, that can get the entire case thrown right out of court. It's that serious. So you've got your perfect copy. Great. But what about the files the user thought they deleted? You see, when you delete a file, the data often isn't actually gone. The computer just removes the pointer to it. So how do you find those digital ghosts? Well, the answer is this really clever technique called file carving. Instead of relying on the file systems map, which is now broken, the software scans the raw data of the entire drive. It's basically a digital scavenger hunt, looking for the specific patterns that mark the beginning and the end of a file. And it works because every file type has its own unique signature, kind of like a secret code. For example, every single JPEG image file in the world begins with the same hexadecimal characters, FFD8. So by searching for these unique signatures, investigators can literally carve out and rebuild deleted photos, documents, and all sorts of crucial evidence right from the raw data. Pretty cool, right? After weeks, maybe even months of analysis, the investigator has pieced together the story from the data. But the job is not done yet. Now, all these highly technical findings have to be presented in a place where technology can be really, really confusing: a courtroom. The whole investigation gets summarized in a final report, and this document is the bridge between the lab and the law. It has to be incredibly detailed for other experts to review, but also clear enough for lawyers, judges, and especially juries to understand the what, the when, and the how of what happened in the digital world. And a lot of the time, the analyst who wrote that report has to take on one last critical role: the expert witness. Their job is to step into the courtroom and basically translate all these complex forensic concepts into plain English, explaining what the digital evidence means and answering some very tough questions under oath. And when they take the stand, their credibility is everything. An expert witness has to be completely objective, sticking only to the facts that the data shows. They have to avoid jargon, never exaggerate their findings, and just be the impartial voice of the digital evidence. In the end, their integrity is just as important as the evidence itself. So, from a chaotic crime scene to a sterile lab, and then a formal courtroom, that's the journey of digital evidence. But with the rise of cloud computing, powerful encryption, and the Internet of Things, that digital crime scene is constantly getting more and more complex. And that leaves us with a final, crucial question. As our world becomes more digital, how will the hunt for truth have to evolve to keep up?